Good afternoon, everybody. Welcome to Wednesday afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. Hi. All right, couple things. First of all, right after today's lab, I will send out the email with the password for the password protected PDF file for test number 2. And once you get it, you'll have until tomorrow, 11 a.m. to take test number 2 and then upload your answers to D2L. And please upload it as a single PDF file. There are files in the assignment area if you haven't figured out how to do that yet, to show you how to do that. Take about an hour or so, hour, 10 minutes. Really, if you've studied, it should take you about 45 minutes max to do the test, but take a little longer. But don't cheat, because I have secret things in my test to catch people, and it works. All right. That's also, I promise, and Dr. White does not like to break promises, by 2 p.m. Sunday, if not a lot earlier, I will, have all your test number 2 score in D2L. I'll also email each of you individually the points you receive for each answer on test number 2. Let me remind you, if you do not have a printer or your printer doesn't work, you can just take a regular piece of paper and then just write your answers with the numbers of what question, and don't forget to put your name on it. And you don't have to rewrite all the questions and make a PDF file and send it up. And that's important information or announcement I wanted to talk about. Remember, you have to get it in by 11 tomorrow. You've got plenty of time to do it. At least I hope you do. All right. Today's game plan, we're going to go back to carboxylic acids, do that for a while. Then we'll do the distillation. I'll say goodbye, and then you take test number 2 when you can. All right, any questions before I begin? Yep, I got my speakers on. That was a big problem when I first started on Zoom. I forget to turn my speakers on. I have these 2 huge speakers right up here. All right, before we get into carboxylic acids, I thought I'd share a little advice with you that has helped me for many years. Every couple of years, you know how you have to go in and get your car tested in Illinois for Illinois Environmental, Act or whatever it is, where they test to make sure your catalytic converter is all right. Years ago, I was section head of process and product development for Axel Chemie, who sold a lot of additives to the petroleum industry, meaning gasoline companies. And because I was one of the few PhD chemists, and that was my area of responsibility, I got the visit and talk to a number of the research groups at different petroleum companies. And I've already shared with you that Shell's the best, and Mobil is almost as good, and other companies, and BP. No. But anyways, one of the things I learned when I was going to these people, because they shared information with me to help me develop stuff for them, was the highest priced gasoline, the highest octane, has the most additives. That's one of the reasons this costs more. And those additives do a lot of good things to your car engine. Then next one is less, and the lowest grade octane has the least, but that's still a very good gas, unless you have a Lamborghini or Ferrari, which right now I don't. So most of the time I just put in, like almost all the time, I put in the lowest octane, the cheapest gas. But I do get it either from Shell or Mobil, most like 99% of the time. And what I've learned, and I also talked it over with some mechanics, and they agreed with what I was doing, is about a week and a half before I have to take my car in for testing, I wait until the tank gets down to about half. I never let it get down below half. And I fill it with the highest octane, most expensive gas, which I did a week and a half ago. And because of the amount of driving I'm doing now, I'll fill it a second time before I go in for my test. Then before the test, in this case, I was coming home from a school in Glen Ellen, I'll take it on the highway and drive it for about 25, 30 minutes. Since I was coming home, you don't go to the testing station with a cold engine. It's not good. And I went there, no problem. I've been doing that for years. So key things: one, put in expensive gas a week or so before if you're driving enough, or at least so you do 2 refills, a half a tank each. And that helps clean out your engine. 2, drive it fast. And well, Dr. White has a radar detector I have for many years, different, and it's called a Passport, and they're the best out there. And yes, I have a lead foot. It's nice on 355. Years before the pandemic, people are doing 65. Now they're doing 75, and I'm doing 70 in the center lane. But anyways, that works. But I'd share that with you. All right, let's get back to carboxylic gases. But I got a question to ask you. Ooh, that looks scary, because I'm looking down here at me, not at the camera. But I have a question to ask you. Did you think about when you passed the gas station that the gasoline contained ethanol, and that's an alcohol? Did you happen to pick up some rubbing alcohol and see it contains isopropyl alcohol, also known as true propanol, and that's an alcohol? Did you pick up some nail polish remover and see that it contains a ketone, acetone? Did you look at a bottle of vodka, or more than look, but if you don't drink, that's okay, and think about vodka and other hard spirits contain ethanol, and that's an alcohol. Remember, organic chemistry is all around us. I stole that from SpongeBob, and it won't hurt for you to think about it outside my class. All right, let's get back to carboxylic acids. All right. Remember, a carboxylic acid, carbonyl hydroxyl group, and an R group on it. And my software likes to draw that way. And remember, carboxylic acid is an acid, a proton donor. And the proton it donates is the hydrogen on the oxygen attached to the carbonyl. And if it donates it to water, you get this, which is the carboxylate anion. And we call this an acid because it donates a proton quite good. And the question is, how come carboxylic acids do that? Alcohols have a hydrogen on an oxygen. Why isn't an alcohol as acidic as something like acetic acid? Remember, acetic acid is the common name for this molecule that you should know the structure, hint. And you take 4% of this, 96% water, and it's called vinegar. Well, let's take a look at this. Switch is off for this right now, but it's still important information you should be aware of. Now, if the carboxylic acid loses that proton, and I'll write it just like this, you get this molecule, which is called the carboxylate anion. Now, one of the things I can do is draw another resonance form. If I take this electron and move it to that carbon, we'll have too many bonds, and an electron moves there. And when that happens, I'm not doing an equilibrium. Double-headed arrow means resonance. I would have this structure. And when you can draw resonance structures for something, it's more stable than when you can't. Now, if I were to do the same thing with an alcohol, this, I can't draw any more resonance forms, and it's quite unstable. Or maybe not unstable, it's not as stable as the carboxylate anion here, where I can draw resonance forms. And because of this proton comes off real easy. It's an acid. This proton is very hard to. This is a really, really, really weak acid, which makes the alkoxide a very strong base. Again, this will never be on a test, but I just thought I'd show you why is an acid, carboxylic acid. All right. Skip the indexer. Anybody reading the book? All right. Let's talk about the following. If you take an acid or react it with a base, you get a neutralization reaction, and this is called the salt. Now, carboxylic acids can do the same thing. Now, right here I have for sodium hydroxide, but after I did this slide, I thought, you know something, there's a better way of showing that, so I better do that. Switch is on. Hint, know this. And if I take on a hydroxide base, other bases will work too, but I'm going to limit it to this class, where M can be sodium, like sodium hydroxide I have in the slide, but I'm also going to include lithium and potassium. And this is an acid. This is a base. It accepts a proton, so this loses a proton, and this gains a proton. You get water, and all molecules have a net zero charge, so this needs this cation. Now, years ago, I had a really good organic chemist, Chem 170 student. Do we have to write the charge? I said, yeah, I'll take points off if you don't on a test. So, well, I don't think we have to. I said, well, if you can show me why, I will not do that. And he did. So if you want to show charges or not, that's up to you. I always will. So let's take this out for a spin. And the question would be, give the organic product or products are the following. And you look at that and say, you don't have to say, but identify what's different. Ooh, oxygens here and here, double bond to a carbon, carbonyl with also hydroxy group and R. This is a carboxylic acid. This is a base, potassium hydroxide. And for this class, M can be sodium, lithium, or in our case, potassium. And you have a acid-base reaction, a proton transfer, and you make the carboxylate anion, also known as carboxylate salt. Now, if you want to put water down, that's optional. Because on a test, I asked for the organic product or products, and water is not organic, it's inorganic. All right, so what's our R group? This. And another way of thinking of it is, do you break carbon-carbon single bonds? No. So I'll have my 3 carbons, my carbonyl, oxygen, minus charge. Whoops, I'm so used to doing sodium. And what's my M? It's potassium, so you get the potassium cation. And you get water. And don't forget, there are 4 bonds to carbon. So I can put in my hydrogens. And that's how you do it. Oh, that was a fun reaction. Let's do another. Remember, I have the fastest mouse wheel, finger to the side, the other side of Mississippi. Always feel free to ask. Can you back up, please? All right. Your turn. What would be the product or product for the following reaction, organic product or products? I'll help you out. Hint. All right, I think everybody's done. So let me get to work. And the question is, what's the organic product or product? 3 points each. What's different here? Look at a molecule, look for what's not carbon, what's not hydrogen. Ooh, oxygen with a hydroxyl group to carbon. Same carbon is double bond to oxygen, carbonyl. And it's got an R group, carboxylic acid. We're reacting it with lithium hydroxide. And the way I wrote the general reaction, M can be sodium. In our case, it is lithium or potassium. And what you get is the carboxylate salt or anion. And here, what's my R group? Isopropyl. Or you can think of it, you break carbon-carbon single bonds, 3 across plus a methyl. Here's my carbonyl. I'll have the oxygen minus charge, and my cation will be lithium. And I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. And that's how you do it. Oh, let's do one more. On test 3, like test 2, I'll have 3 or 4 synthesis problems. And the question is, what do you react with sodium hydroxide to make that molecule? All right, looks like everybody's done. So I better get to work. What is this? Oh, it's a carboxylate anion. Well, I've got a benzene ring, but I'm going to think of that as R, carbonyl, oxygen, a minus sign, and a cation. Remember, M can be sodium, which in this case it is, lithium, or potassium. And what do you react? A carboxylic acid plus a base, and you'll get this. What's my R group? Benzene ring. So my starting material here would be benzoic acid. And you react it with sodium hydroxide, and you do it in a solvent. I've never done solid state chemistry myself personally, mixing solids together. There is a branch chemistry that does that. And by the way, one of the things you should be asking yourself is, why am I learning this stuff? And the obvious answer is you want to get a good grade in this course so you can get into a program or a school. Well, why learn this stuff? Really? Besides that important reason, this is called, I'll teach you the nomenclature later, sodium benzoate. And sodium benzoate is a molecule in our daily life. No, yes. If you look at a can of pop or a bottle of pop and look near the end of the label, you will see sodium benzoate. And sodium benzoate is a preservative used for pop. Remember, Dr. White grew up in the Chicagoland area where we call a carbonated beverage in a can or a bottle that's non-alcoholic pop, not soda. And this is used as a preservative. Now, how it does it, I have no idea. I know how to make it, but I don't know how it actually preserves pop so you can keep a case for a while in your home. Now, there's a special base I'd like to talk about, and that's sodium bicarbonate right here, which you also know as baking powder. If you take a carboxylic acid and react it with sodium bicarbonate, baking powder, you get 3 products. And I'm going to switch over to my whiteboard because there's something I want to do. And the first product is you get a carboxylate anion, because this is a base, mild base, but it's still a base. And it'll react with an acid, which is the carboxylic acid, but you get 2 more products, water plus carbon dioxide, CO2, and the arrow here means it's given off as a gas. Now, how does this happen? Well, let's look at it. What I'm going to do now will not be on a test, but I thought I'd show it to you. This is what the structure of sodium bicarbonate looks like. And when it accepts a proton, what you get is, oops, that up. What you get is the carboxylate anion plus when the proton transfers over here, you get this molecule. And when I'm writing now, you don't have to ever know for a test. I'm putting it in brackets because it cannot be isolated. This is called carbonic acid, and it breaks down to something very quick. If I lose this H and this OH, I'll get water. And what's left behind? One carbon and two oxygens. This immediately breaks down whenever it's formed to form water and carbon dioxide. So let's take a look at the following. Remember, carboxylic acid plus sodium bicarbonate baking powder gives you carboxylate anion, water, carbon dioxide. And the question is give, and notice I have underlined all products, not just the organic, all products for the following reaction. And here it is. And I'll do this one, and I'm going to share one with you. And that is, what functional group is this? Oh, oxygen here, carbonyl, carbon double bond oxygen, and hydroxyl group on the same carbon. It's a carboxylic acid with our group here. And then I have sodium bicarbonate, baking powder, and what you get are three products. The carboxylate anion, water, and carbon dioxide given off as a gas. So if I look at this, what's my R group? Three carbons. Then my carbonyl, oxygen O minus and A plus. Remember, there's 4 bonds to carbon. So I can put in my hydrogens, and you get water plus carbon dioxide given off as a gas. And that's how you do it. Oh, let's have you try one. And it's your turn to try one. Give all the products, not just the organic, all the products. All right, looks like everybody's done. What do we have here that's different? What's not carbon? What's not hydrogen? Oh, oxygen with a hydrogen on a carbon. Also has a carbon double bond to oxygen. And this is a carboxylic acid. And we're reacting with sodium bicarbonate, which is a base. So we're going to have an acid-base reaction, otherwise known as the neutralization reaction, to give these three products. And if I look at this, what's my R? So I'm going to have this, my carbonyl, O minus, Na plus water, plus CO2 given off as a gas. Oh, let's do one more. I'm having a good time with this. And here's one more for you to do. All right, looks like everybody's done, so I should get to work. And what do we have here that's different? Hydroxyl group and oxygen's the same carbon, and it's got carbons on it. This is a carboxylic acid. Baking powder, what do you get? Acid-base reaction. You get the carboxylate anion of the carboxylic acid you would have started with. And you get water plus carbon dioxide given off as a gas. By the way, carbon dioxide are those little bubbles in like pop or beer or champagne. And also when you burp out carbon dioxide. So what's my R group? Methyl. So you get this carboxylate anion plus water plus carbon dioxide given off as a gas. Anybody see the significance of that reaction? I'm waiting. Obviously not. Well, let me tell you. What is this carboxylic acid? Acetic acid, which is the common name. Nobody ever calls it ethanoic acid. And if you take acetic acid and water, you get vinegar. And what this really shows you is, if you take vinegar and sodium bicarbonate mixed together, you'll get this, and a lot of bubbles formed from the gas. Now, it's time for me to share a very special story. My father, God bless him, was a pharmacist who loved chemistry. Why did I become a chemist? I don't know. But anyways, he loved chemistry. And when I was about 6 or 7, we used to do chemical experiments together. And he knew a lot of chemistry. He liked it, obviously, so do I. And when I was about 7, the most important thing happening in the world, especially the United States, was the space race between the United States and the evil Soviet Union, which was mainly, Russia and satellite countries, which have since broken up, even though Putin's trying to put it back together. I hope not. But anyways, all toys and everything were space related. And one of the things you could go for, I think it cost only a penny. Don't forget, salaries back then were a lot lower than now, was this, and it looked like this. By the way, you can laugh about my drawing. Dr. White will never go to art school. This hollow tube that had a cap on it that had fins, so it was a little rocket ship. And inside there were these little dots of the most awful candy in the world. How do you know it was awful? Because when a 5 or 6 or 7-year-old got this, he'd take the cap off, take the candy, dump it in a garbage can, not even try and eat it because he knew, and I knew, my friends knew it was awful, and use that as a rocket ship. Well, what you had after you dumped the candy, this is a hollow tube. My father showed me, and I showed my friends, if you take that hollow tube, turn it upside down, put some vinegar in there, which is acetic acid, then put some baking powder in real quick, slam the cap back on, shake it up and hold it by its fin. Guess what happens? Inside here, carbon dioxide builds up. You got gas pressure. All of a sudden, the tube pops off and goes flying. And if your timing was good, it could go about 4 or 5 feet. And when you're 7 years old, that's cool. And I showed my friends, and they loved it. Now, I do have to warn you, my best friend at the time, and I haven't talked to him in decades. I don't know if he's still alive even. He left, his family moved out of the state. This one, we lived in Chicago, my parents and I, my sisters. He used all his mother's baking powder and didn't tell her. She went to cook something where she needed it. She didn't have it. Boy, was she mad. And boy, did he catch it. So if you use all your mother's baking powder or vinegar, make sure you tell her so she can buy more. Now, also, it's time for a Dr. White's secret. My father loved to cook. My mother was a very good cook. My father was even a better one. And because of his hours he worked, back then he owned a drugstore and he spent a lot of time there. On Sundays, sometimes when he had the time, he would cook. And he'd tell everybody, it's men's only cooking this Sunday. And we go in the kitchen and cook. And we had a huge freezer where we could make a lot of stuff, package it and freeze it. So, and I, to this day, I have a huge freezer in my utility room, huge. It makes this cabinet look tiny. It's about 6 foot by 4 by 3. It's huge, biggest one you can buy. And we'd make a lot. And one of the things he loved to make was spaghetti sauce. And I don't know where he learned it. There are 2 things he learned. First of all, have you ever made spaghetti sauce and it doesn't taste like the good stuff at the top Italian restaurants? One of the secrets is they put just a pinch of cinnamon in there and it makes the taste like the good stuff. And when you have, and we'd make like a 3-gallon pot of this, and you had the tomatoes, and we actually hand crushed tomatoes with had a hand crusher that had a blade and you handle and you crush them. And we'd use tomato paste and tomato sauce and had herbs in there and garlic and onions. But you put a small pinch in a 3-gallon pot, no more than 1/8 of a teaspoon. I had a friend of mine I taught that trick, or not trick, that thing to, and he made a small pot of a 1/4 or 2, and he put a tablespoon of cinnamon in there. Boy, he called me up complaining, I can't even taste the tomatoes, it just tastes cinnamon. I said, I told you, just put a little bit. Now, the other thing, I don't know how my father found out about this or came up with it. I never asked him, I was too young to think about things like that, was near the end, when you made it, you put in less salt than you normally would have done with a regular tomato spaghetti sauce recipe. At the end, with a big pot, I'm talking about 3 gallons, you put in about 1.5 teaspoons of baking powder. What does that do? Well, tomatoes contain citric acid. That's why if you have a canker sore in your mouth and you have anything with ketchup on, all of a sudden, ooh, that hurts, it burns, because the citric acid gets in there and gets you. Well, he found that if he puts in a big pot, say about a tablespoon of baking powder, the tough stuff tastes smooth. I mean, really good smooth. And what is it doing? Citric acid, and I won't draw the structure, I'll just do in general. is an acid. And when you add sodium bicarbonate, you're neutralizing some of this. And you form the carboxylate anion. And this is a salt. Your tongue thinks it tastes like salt, sodium chloride. And you make water, and you'll see in the pot a lot of bubbles and white foam, which dissipates after it's all reacted. And what it does is this increases the pH, which means you're making it less acidic. We'll be doing a lab later on face-to-face if we were, we do it. We use some dangerous chemicals. One of them is tomato paste, dangerous stuff. Anyways, and it makes it taste real smooth. Now, a couple of years ago, I had a Chem 170 student, and about 2 or 3 weeks after I just taught what I taught you, my father's secrets for making the best spaghetti sauce, and one of them is putting just a pinch of cinnamon and at the end some sodium bicarbonate, not a lot. And she came to me and said, like, my father asked me to tell you thank you. And I'd like to thank you. And I said, all right, you're welcome. What are you thanking me for? Well, we made your spaghetti sauce the way you, with the cinnamon and more importantly, with the baking powder. And I really like to thank you. And I said, well, you're welcome. What's so special about it for you? Says, my father and I suffer from acid reflux. And that's where your stomach acids come up your esophagus. I'm not a doctor. And I had one company I worked at, another manager had it, and it was so painful. He actually had to have an operation to stop that from happening. And she was saying, my father and I love Italian food, especially spaghetti and meatballs. But whenever we eat that, even if we made it ourselves, we'd suffer from the acid in the spaghetti sauce, the tomatoes. But when you put in the baking powder, that makes it less acidic, increases the pH. And guess what? We didn't suffer. Thank you. We can now enjoy our spaghetti and meatballs. So organic chemistry is everywhere, even in the kitchen. All right, now, switch is off, but I just thought it's important to make, why am I learning this in real life examples? In pops, sodium benzoate, which we made earlier, is a preservative. Now, how many of you have ever gone to a supermarket, bought a loaf of bread, or gone to a bakery, bought some bakery goods or bread, and the next day you can still use it? There's nothing green growing on it. Why? Because they use calcium propanoate, which has this structure, and the switch is off now. This carboxylate anion, you need 2 of these because this is a +2 cation. All molecules have a net zero charge. And that is used as a preservative to keep bread from going moldy. Now, how that does that, I have no idea. I'm an organic chemist. It's not an area I studied, but I know how to make that stuff. And we'll learn later on a special carboxylate anion, this one, that's an A, when C plus R is 16 to 18 carbons, that's your bar soap. Next time you wash your hands with bar soap or take a shower with it, I don't like the, what do they call them, body soaps. They leave a film on my skin that bar soap doesn't, so I don't like using them. That's my personal preference. But we'll talk more about soap later in the semester. And one more thing I'd like to share, carboxylate anion. How many of you have heard that you should get your calcium because it helps with keep strong bones? I think hopefully all of you have. And what you're really taking is not calcium metal. That'd be like eating gold. You're having this molecule, which is a carboxylate anion. It's called calcium citrate. And citric acid has 3 carboxylic acids. And what you do is you take citric acid and react it with, say, something like calcium carbonate, which is a base, and you form this carboxylate anion. And that's what you actually consume to get the calcium +2 cations to keep your bones nice and strong. And so you don't get something that's sad to see in people, that's osteoporosis. If you've ever seen old people are really stooped over, can't stand up straight, that's the reason. Medical science tells us. All right, how do you make a carboxylic acid? Well, one way is oxidation of a primary alcohol. But wait, you're going to say, Dr. White, for test 2, primary alcohol makes an aldehyde. And the answer is yes, it does. Now, what I'm not teaching in this class is about oxidizing agents and reaction conditions. Temperature is important, and you can either stop at an aldehyde or go all the way to carboxylic acid. For test 2, don't forget it's an aldehyde. For test 3, it's a carboxylic acid. And O, bracket O, close bracket, is an oxidizing agent. So if you take a primary alcohol and oxidize it, and use what's called either a strong oxidizing agent or you heat this up so it's much more reactive reaction or active reaction. So let's take this first spin. And if we look at this, what's different? Ooh, hydroxy group on a carbon. And it's also a primary alcohol. Or this is my R group. This carbon here is this carbon here. When I oxidize it, I'll convert this into a carboxylic acid. And therefore, you break carbon-carbon single bonds, 3 across my R group. This carbon here, which is this carbon here, which becomes my carbonyl carbon. And I'll also have a hydroxyl group attached to that. And I know there's 4 bonds to carbon. And you'll get that carboxylic acid, propanoic acid. If I look at time, it's time for a break. Come back in 5 minutes and we'll continue. Let's do that again. Time to get going. Instant replay. All right, let's continue. We're talking about oxidizing a primary alcohol to make a carboxylic acid. So let's have you try one. And the question would be, what's the organic product or products for the following reaction? 3 points each. Isn't it nice how I shared a fun with you? Don't answer that. If I say fun enough times, you might believe me. All right, looks like everybody's done, so let's proceed. And if we look at this molecule, look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen with a hydrogen and a carbon with other carbons. It's a primary alcohol. And if we oxidize it, what do you get? A carboxylic acid. And what's my R group? Whatsoever attached to the carbon with the hydroxyl group on it. Therefore, I have 1, 2, 3, 4 carbons. That's my R group. Then I'll have my carbonyl hydroxyl group, carboxylic acid. And notice I have 1, 2, 3, 4, 5. I end up with 1, 2, 3, 4, 5, because you don't break carbon-carbon single bonds, except for combustion. And I know there's 4 bonds to carbon. And there's my molecule. Oh, let's do one more. These are enjoyable. What would I oxidize to make that molecule? Remember, I will have a couple synthesis problems on test 3, like I'm going to be doing in test 2. So here's some practice. All right, I think everybody's done, but let me just check with the poll. If I were in a classroom, I could just look around and see everybody was done, but not everybody's got their webcam on. So that's why I have to use the poll. Did my chemistry guilt do anything to turn on your webcam? All right, let's get going. What do we have that's different? A carboxylic acid, carbonyl, hydroxyl group, the same carbon. And what do you oxidize? to make that a primary alcohol. What's my R group? This. Therefore, I have these 4 carbons, and it's attached to this carbon, which has an alcohol on it. I know there are 4 bonds, oops, hold on, 4 bonds to carbon, and that's what you get. You know something, I gotta do one more of these. I should say, I'll let you do one. Oh, let's make it a simple one. There you go. What would be the product or products for the following reaction? 3 points each. Oh, excuse me. Got up too early this morning. I started work this morning about 4:30. Usually I like to sleep till about 5:30. And everybody's done, so I better get to work. And what's different here? Ooh, hydroxyl group on a carbon, a primary alcohol. I'm oxidizing it. And what do I get? A carboxolic acid. What's my R group? Oh, a methyl group. So I have a methyl group. This carbon is this carbon, becomes this carbon, a carbonyl with a hydroxyl group, and I get a carboxolic acid. Now, does anybody see the significance of that reaction? Again, this is one of those times, why am I learning this stuff?
Yeah, you made acetic acid.
And what alcohol are you starting with?
Ethanoic acid.
Ethanol. How many of you have ever tasted wine that's gone bad? And what does it taste like? Vinegar. Why? What happens? Well, if they didn't seal the bottle correctly, air gets in there. Air is a very slow oxidizing agent, very slow. And if you have a bottle of wine that's been around for a while, there's air in there. Some of the ethanol, which is in wine, is oxidized to acetic acid. And remember, acetic acid and water is vinegar, which is why it tastes like vinegar if it's gone bad. Now, one of my fraternity brothers, where I went to school, IIT, which was back then really a new area, got into computer programming. And he is really good at it. And after he graduated a couple of years later, when banks were starting to computerize, that's how old I am, they weren't a long time ago, he did some big banks in New York, and then he got this couple of customers in the Cayman Islands. Cayman Islands, that's where the rich people hide their money. And he did computer work for them and was making a lot of money. And he loved wines. And at that time, he lived in a condo. He had a whole wall in his living room where he could store bottles of wine. And when it filled up, he'd invite a bunch of us over and say, we got to drink some of my wine. because I want to buy some more wine. He was that much of a connoisseur. And these bottles, this is back in the late 70s, early 80s, were $100, $200 a piece. Once in a while, he'd open one up, we'd taste it. Went bad, tastes like vinegar. But you never thought you learned that about wine in a chemistry class. All right, let's move on. Now, you can also oxidize aldehydes. You take an aldehyde and oxidize it, you will get a carboxylic acid. In fact, this reaction I actually did you needed to use it for my PhD thesis research in order to make certain carboxylic acids that I made into other compounds needed for my research. And therefore, it's a familiar one to me. So let's have some fun with it. Now, if we look at this molecule, what would be the reaction product if you oxidized it, which is what that means. Well, what's different? Ooh, carbonyl with a hydrogen carbons. This is an aldehyde, which I hope you know in a little while when you take test number 2. But this reaction won't be on there. And you can oxidize it to get a carboxylic acid. The only change it makes is that H becomes OH. So here's my R group. It's unchanged, 3 carbons. I have my carbonyl. And this will have a hydroxyl group, this. And I know there are 4 bonds to carbon, so I can put in the hydrogens. Your turn. All right, let's get going. What's different here? What's not carbon? What's not? Ooh, oxygen double bond to carbon, carbonyl with a hydrogen carbons, aldehyde. When I oxidize it, what do I get? A carboxylic acid. And now, what's my R group? This. 3 carbons across 2 methyls. Then this carbon here, which is this one, becomes this one here. And it has the hydrox group attached to it. And that's the carboxylic acid you made. And let's do a synthesis problem. Let's see if you're up to it. Oops. Hold on. I'm having a bad ring day. I have bad hair days. Oh, don't look. But anyways, you can have a bad ring drawing day. Let's see if I can do a better one. What would you start and oxidize it to make this compound? Actually, there's more than one answer, but here I'm looking for the aldehyde. All right, my turn. And if we look at this molecule, what's different? Well, we've got a benzene ring, but benzene rings don't react or form with an oxidizing agent. They don't. So I'm going to call this R. What do we have here? Ooh, carbonyl with the hydroxyl group, a carboxylic acid. What do you oxidize to form a carboxylic acid and aldehyde? So what would be the starting material? Benzaldehyde. Now, when we do this in the class, next time we're in the lab, I bring out a bottle of this compound. Remember, you smelled it. If we were in the lab, you would have smelled it. And it smells like cherries or almonds. Now, benzaldehyde is a liquid. And if you open the bottle of benzaldehyde and look at the threads around the top of the bottle where the cap goes, you'll see a white solid. What does that mean? Well, what happens is the air, mainly really the oxygen in the air, if there's any benzaldehyde on the threads of the bottle, then it happens pretty quickly, get oxidized to benzoic acid. This is a liquid. This is a white solid. And that's what forms on the threads. The air you breathe very quickly oxidizes the benzaldehyde to benzoic acid, which is why we usually put stuff on the bottle cap to make sure no air gets into the threads. All right, let's continue. Uh-oh. Yep. Don't know why this happens. All right, everybody see reaction of a Grignard reagent with carbon dioxide on your screen? Thumbs up, people. Thank you. And this should be also this. Oops. Now, this reaction is really cool. And when I mean really cool, I mean really cool. And that's the reaction of a Grignard reagent with carbon dioxide, second step acid and water. Now, let's take a look at this reaction. And it allows you to make a carboxylic acid that's one carbon longer than the R group you started with. Now, I'm going to show you something I wish I had time to do for all my reactions I show you, or not mine, the reactions I show you, but we just only have 16 weeks. But this one I thought I'd show you. Carbon dioxide, what's the structure of carbon dioxide? Looks like two carbonyls to the same carbon. And Grignard, oops. You learn for ketones and aldehyde, the Grignard reagent attacks the carbonyl carbon. Well, this one it does too. And forms this carboxylate anion, which is a base. So when I add acid and water, it protonates this to carboxylic acid. And why do I say this is a really cool reaction? Because in the lab, what you do in a solvent, you use dry ice. I don't know if you've ever worked or played with dry ice. I have both. And dry ice in, say, isopropanol, the temperature is this. It's really cold, minus 78 degrees Celsius. So again, the Grignard reaction is where you take a Grignard with carbon dioxide and you make a carboxylic acid that's one carbon longer than the R group you started with. And I've done this to make a carboxylic acid in a research lab for my PhD thesis. It's fun. Oops. And the carbon with the Grignard is the carbonyl of the new carboxylic acid. This carbon is on the carbon here that this was on in R. Remember, H plus is this acid like sulfuric acid. And what do we have here? Carbon, carbon. Oh, magnesium chloride. It's a Grignard. Remember, X can be chlorine, bromine, or iodine. And you react it with CO2, second step acid, H plus and water, and you get a carboxylic acid that's one carbon longer. What's my R group here? Two carbons. Two carbons. I'll add this right here. And now I can put in my hydrogens. I know there's 4 bonds to carbon. And that's how you do this reaction. And why don't you try this one? What would be the product or products for the following reaction? By the way, this reaction, I don't think I've ever and ever will put a synthesis problem on the test. It's a little hard for students. So for this level chemistry, organic chemistry. So this reaction, general reaction, will never be in a synthesis problem. All right, I think everybody's done. Well, let me check. Don't be lazy, Dr. White. Use the bowl. And I was right. All right, what's different? Ooh, a magnesium iodide on a carbon. This is a Grignard. Remember, X can be chlorine, bromine, or iodide. In this case, it is iodide. And we're reacting with CO2, second step, acid and water, and you get a carboxylic acid that's one carbon longer than the R group you started with. Well, what's my R group? This. And don't forget the carbonyl carbon is bonded to the carbon in R that the magnesium was bonded to. This is my R group, isopropyl. Center carbon has the Grignard, so that will be bonded to my carboxylic acid. And notice I started with 3, I end up with 4, so I have one more carbon. And this is one of those special reactions that you make a carbon-carbon single bond. Very special, very rare. Oh, let's do one more. And there's that one more for you to try. All right, let's take a look at this. What's different? In a couple of weeks, you might be having nightmares. I'm saying, what's different? I hope not. But anyways, I always look at a molecule, look what's not carbon, what's not, ooh, magnesium chloride on a carbon. And this is a Grignard. X can be, in this case, it is chlorine. It can be bromine or iodide. And we're reacting with carbon dioxide Second step, acid and water. And you get a carboxylic acid that's 1 carbon longer than the R group you started with. And you've made a carbon-carbon single bond. Well, what's my R group? This. So I'm going to have my ring, my methyl group, and what carbon has the Grignard? This one. I have my carbonyl and hydroxyl group. And that's how you make a carboxylic acid a really cool way, using dry ice. It's fun. Oh no! Guess what time it is? It's new functional group time. And this new functional group is called carboxylic acid derivatives. Now, the term derivative means derived from, which means these are new functional groups that are made from carboxylic acids. And what you do is in a compound which the hydroxyl group of a carboxylic acid is replaced with other things. And I'll never ask you what is a carboxylic acid derivative. All right. First one we'll talk about is an ester. And an ester has an R group, carbonyl, oxygen, and then on the oxygen, there are carbons we call R prime. And that's an ester. Now, because we only have so many weeks and I've decided to spend more time near the end of the semester on things that are more interesting to you as opposed to me, like fats and oils, carbohydrates, proteins, and amino acids, are certain functional groups I'd like to talk about, but I just don't have the time. And that is an acid halide. And I work with acid halides, I worked with esters. And this is where X can be, again, chlorine, bromine, or iodine. And these are really useful. And these are like a carboxylic acids, but much more reactive. I mean, much more. So the key one we're going to talk about is the ester. And ester has that functional group, carbonyl, R group, oxygen to the carbonyl, and on the oxygen, more carbons. Hold on, I'm getting it. Did a lot of walking, exercising yesterday, and getting a cramp in one of my legs. I had to stretch out. Sorry about that. And we'll talk about an ester. Now, there are other carboxylic acid derivatives that I just can't get into. Like this one is called the acid anhydride, which I've also worked with. But we're going to talk about esters. And what's an ester? It's derived, meaning it's made from carboxylic acids. And you replace the hydroxyl group with an R with carbons on it, ester. And here on my whiteboard, I have drawn a molecule. And the question is, what functional group is it? And if we look at it, what's different? Ooh, oxygen's here and here. We have a carbonyl. On the carbonyl, I have carbons. I'll call that R. And I have an oxygen. And on the oxygens, I have more carbons. And I'll call that R prime. And what do we have? We have an ester. Do I have time? Ooh, I do. Now, a couple of years ago, I was teaching the same class in COD. It was called 1212, and I'll be doing it that summer. But also, by the way, spread the word. If you know anybody who needs organic, I'll be teaching it this summer on the Zoom through Elgin Community College. And years ago, the first time I was taught it in the summer, I said, this is going to be impossible. How good will the students do? And for some reason, they actually do better in the summer than they do in the fall and spring, even though my fall and spring class do real good too. So I'm teaching that. But anyways, I'm going to have to take a break in a minute and stretch. But anyways, I had in that class a woman whose name was Esther. And when I was doing this section, I said, here we have an Ester. I could see her head would snap and say, "Did you call me?" I said, "No, I'm talking about the functional group." She was glad when we got through an Ester functional group. She wouldn't always think I'm calling on her. I don't do that to students ever, but it was funny. So this is an Ester. And I think this would be a good time to take a break and we'll come back to the lab. I'll let you out early today so you can start on it, because I've got to get up and stretch this leg because it's keeping on tightening up on me, which is not a fun thing. So right now, let's come back at 2:37. I know it's a little odd time. Let's take a 5-minute break so I can do some stretching exercises so it won't cramp up on me. I'll see you in 5. 2:37. The joys of having mature muscles. Actually, I started a day or two ago back to really doing some serious power walking. And when I do that, plus teaching at the other school on my feet all the time, that will happen. And I didn't stretch as much as I should have this morning. All right, it's lab time. Well, first of all, I got to get everybody back. Time to get going. It's lab time. And today's lab deals with distillation. Now, we don't teach this lab here at another school. We do. How do you purify a solid organic material? Use something called a recrystallization. Well, what if you have a mixture of liquids and you want to get them pure substance out of it? Use what's called the distillation. And by the way, I've done a lot of distillations in my life. And let's go to the lab. Today's lab deals with purification by distillation. And it's just a way of getting you to understand how you can purify organic liquids. Now, all compounds that are liquids boil. Now, what happens when something boils? Well, you get a vapor pressure above the liquid. And when that vapor pressure is equal to atmospheric pressure, that temperature is called the boiling point. Now, have you ever seen a pot of water boil? You know how you see all those bubbles coming up? Well, what happens then when you boil any liquid, the vapor in the liquid collects inside to form bubbles. And these bubbles rise and collapse. I like that, collapse. And didn't know I'd have special effects in this lab. And that vapor that comes out of the bubbles is on top of the liquid. Now, if you were to cool that vapor again, it would condense and become a liquid again. How many of you in the winter take a hot shower, and if you don't have a good exhaust fan in your bathroom? I do. For years I did, and then a number of years ago I got it replaced, and I got a really good one. But on the mirror, or if you have a window in your bathroom, on the pane of the glass of the window, you see moisture condense on there, form. And that's because that's cold surface. And when you take a hot shower in your bathroom, you have a lot of water vapor, and that condenses on the cold surface. And we use this in what's called the distillation. Now, when you slowly heat an organic compound that's liquid, the vapors will rise and the temperature will rise until the temperature reaches a constant value, and that's of the vapor. I should have it here. And that temperature, when it levels off and you're getting a pure compound coming over, I'll explain what I mean by coming over in a second or maybe 10 seconds, that's called the boiling point of that compound. Now, in the lab, we use this apparatus. It's all hooked together. And part of the fun part, at least I think so, students don't always, is putting it together, learning how to construct it. Now, here we have what's called a round bottom flask. And we have a distillation head, thermometer adapter, thermometer right here. Now, a couple of years ago, with the help of Dr. Daly, who's the lab manager, and he also teaches organic the 2 semester, we were able to replace the thermometers, glass ones, with thermocouples that read to a digital readout. So we had digital thermometers, which make life so much nicer. Now, this is all connected together. So this is connected inside that. If you notice here on this drawing, you see this sort of like little spots and a rough surface on this part, and same thing here. This is called a ground glass joint. And you lubricate these with what's called vacuum grease. So you can put them together, but at the same time, and when you put them together, they form a nice seal, and then you can pull it apart later on when you want to. Now, over here, we have the condenser. Now, when this is all connected together and you heat this, the vapor comes up here, comes over here. Remember, it's all connected. And in this condenser, there are two tubes, the inner tube and the outer tube, and they're not connected. And this is important for you to know. In a condenser, water always comes in at the bottom and it comes out at the top. If you hooked it up the reverse, this would never fill up, because all around here, this fills up with water and it pushes out this way. And it's cold water. And so when the vapor comes in here, the cold water here condenses it to liquid. And it goes, this is again connected, and it comes here, and it drips down here, which you collect. Now, right here, to heat it up, it looks like an electric blanket that's molded. We use what's called a heating mantle. And this is hooked up to a controller, which then goes to your wall plug. And the controller controls how much heat this provides to the round bottom. And by doing this slowly, if you have a mixture of things, one thing will boil off and you collect it, change this, and put when the next thing comes over, the temperature goes to a different level, and you collect it when it levels off. And that's called a fractional distillation, which we won't be doing, or you wouldn't be doing. Now, there's something important I need to teach you. First of all, let me remind you, in a condenser, water always goes in at the bottom. And that's to keep this full of water. And that's important. Now, there's something I have to teach you about heating or boiling liquids in glass. I'm sure all of you, I hope you do, have boiled water sometime in the kitchen, and you have a pot or pan and it's made out of metal. And even though you touch the surface of the metal and it feels smooth, if you really magnified it, it's rough like the Grand Canyon. Now, if you have glass, I don't have any glass. Oh, I do. Glass, then even if it's got scratches in there, it's smooth compared to metal. And that's important for the following reason. And if I had just a beaker of water, and the same thing is true on a hot plate, I have some water or any liquid. When I'm heating it up, you're going to form bubbles. But if you have it in glass, what happens is you form big bubbles, and they come to the surface and they splash everything out. And that's bad. In organic chemistry, we call that bumping. So how do we stop bumping in glass? We put in here boiling chips. Now, there are two types of boiling chips, and boiling chips are just rough surface, inert material, little small pieces. And you only need 3 or 4 and like a round bottom to stop bumping, and which you don't want. And boiling chips are either made of marble, they're the cheaper kind, and at COD, that's what they buy. And at ECC, we get the good stuff, which is a carbondium inert metal, which are also rough. And what happens is the gas that's formed when you heat a liquid can coalesce and form bubbles on the rough surfaces. In a metal pot, you've got those at the bottom. In glass, you don't. And therefore, it's always important to put boiling chips into the round bottom flask. And most of the lab would be setting this up. And when I do teach this face-to-face, before you plug the controller into the wall socket, and before you turn on the water, you hook a rubber hose to water outlet to this, and this goes a rubber tube to the sink. I say, let me come over and you show me your setup. So I check to make sure it's correct and you won't hurt yourself, which is important. Now, here are a couple of YouTube's videos I'll let you watch on your own to see how this is really set up. And another important thing when you're doing a distillation is you never get the distillation flask go to dryness. Why? Because certain organic chemical residues, when they get dry and then heat up, explode. That's not a good thing. Trust me, that's never happened to me, but I don't want it ever to happen. So always stop your distillation before the round bottom goes dry. Now, when we do this face-to-face, what I do is I have the students put in 30 milliliters in the round bottom. This is a small one. We use much bigger ones. This is a 15 milliliter. And they're only taking out 15 milliliters, 12, 15 milliliters. So there's always going to be a lot left. And when you're done, you take the round bottom and the heating mantle and lower it and let the round bottom cool off and then get rid of the waste. Now, in this lab, you'd add 30 milliliters of a hexane to a round bottom flask through a glass funnel, add a couple boiling chips. And before you heat it up, I actually look personally that each group has boiling chips in there because you don't want it to bump. I actually saw in a lab where some idiot who should have known better, this was in grad school, did a distillation, forgot to put the boiling chips in. We had a thermometer of that type, and the bumping caused the thermometer to fly straight up and get stuck in the ceiling of the room we were in. Boy, did we give him hell for doing something that was quite dangerous and could have hurt him and people around him. He learned his lesson. In grad school, people who did dumb things were educated very quickly how dumb they were. Nothing personal, but it's dangerous. And what you would be doing is slowly turning on the water, and you don't need a lot of water, and then you slowly heat it. And all of a sudden you see drops, vapor coming up, and then drops coming down, and you'd have a graduated cylinder and collect it. And every 2 milliliters, you would record the temperature. Now, when the temperature is sort of flattened out, that's your boiling point. When the temperature is sort of flattened out, it'll vary a little, that's your boiling point. Now, if we go back to the distillation apparatus, when you have, instead of a beaker here, a round bottom or another thing, you can pull a vacuum on this. And by pulling a vacuum, you need less energy to get the vapor pressure equal to the vacuum pressure. That's called a vacuum distillation. And that allows you to use less heat. Things boil at a lower temperature in a vacuum, just like in outer space, water instantly boils because there's no air pressure in outer space. But anyways, and I've done vacuum distillations. Now, how many of you have ever seen a TV program or read about moonshiners? Those are people, started in the South of the United States, in Kentucky, Tennessee, and there around, where they had states and still do that outlaw alcohol consumption. And because of that, in sales, and I'm not telling you should ever do this, but in the middle of nowhere, because it's illegal, they ferment different things to make ethanol, alcohol, and distill it out. And that distillation, what they make is called moonshine, because they did it at night under the moon. Obvious, not really. But if you ever see one, they have a pot with a fire underneath, like the round bottom. Then on top, a long copper coil. And in the TV programs recently, you see them putting it into a different type of setup where they use what's a better condenser. Well, that long coil is that way because the air cools down the vapor and is not as effective as cold water. And therefore, that's why they need the longer space. And what the moonshiners are really doing is the distillation. And what do they call their apparatus? It's called a still, short from a distillation apparatus. But you never thought they were doing chemistry. They are. And for this lab, I have some questions for you to answer. Now, one last thing I'd like to share with you before I let you go. How many of you have seen, well, I'll show it to you now. You see my picture I use when I'm not having the video on? This is a very special short path distillation apparatus, which I used heavily in grad school. A number of years ago, way after I graduated, on eBay, I was able to buy one. Isn't that cute? And it's for dealing with small amounts. It's a small round bottom. See how this, by the way, that's called the male joint, and that's called the female joint. One goes in the other, and you have it lubricated. Now, this one is very small. The one you do in the lab is 10 times bigger than this. Ooh, little piece of dirt there. And you'd have a thermometer here. The vapor would come up here. You got a tiny little condenser here, inner tube, and the outer one, water goes in here, out here. This is if you do a vacuum distillation, and you can have another one to collect it here. And I used this a lot in grad school. And when a couple of years afterward, when I saw one on sale on eBay for a reasonable price, it brought back memories and said, I want it. And guess what? I bought it. But this is a distillation, one-piece distillation. This used to be called bantamware. And I had a whole lot of bantamware, not only mine, but other people in my research group at Michigan State. We had a lot of money too, our research group. Our advisor got a lot of nice grant money. So we had a lot of neat equipment like that. I think I've covered everything. So with that, I'm going to say, gang gesund. Don't forget, I have my office hour tonight if you have any questions, or you can email me about test number 2. In about 5 minutes or less, I will send out the password email for test number 2, so you can get started on it. And you have until tomorrow, 11 a.m. to upload it as a single PDF file to the assignment area. And by Sunday, 2 p.m. at the latest, hopefully earlier, I will have sent out, first of all, post in D2L your test score total. And I'll send out an email, an announcement that's there. At the same time, I'll also send out within that time or shortly after, I already have, I'll send out individual emails like I did with test 1, that what points you got for each answer. Now, don't forget 4 bonds to carbon. And do you break carbon-carbon single bonds? No. And don't forget that. And I think that's it. If you have any problems, let me know. Oh, one last thing. Next Monday in class, and I'll cut it out of video, I will go through all the answers for test number 2. If you can't come to class, come to my office hour. I'll be more than happy to share any answers with you. I just don't want to put it in a video. And I'm going to be a little while making non-public Monday's video, and I won't post this one until tomorrow morning, because 2 semesters ago, I found some students were cheating and looking at the review while taking the test. And I found a way to find that out. And so this makes it less tempting for students. With that, if you have any questions, stick around. If not, I'll say, gang gesund. I'll either see you in my office hour or I'll see you on Monday. Good luck on test number 2. Hopefully you won't need luck. Bye now. Gang gesund. I stole that from Granny and the Beverly Hillbillies.